Hello, I'm Ashmit Kalra, Senior Solutions Architect at AWS. Today, I'm going to talk about how to use fully managed Jupyter notebooks in Amazon SageMaker. Today, we are going to cover the following topics. We're going to start talking about what is Amazon SageMaker and then look at what are notebook instances. Then we'll further dive into Studio environment and Amazon SageMaker Studio notebooks and understand the difference between notebook instances and Studio notebooks. Moving on, we'll look at some of the core features and understand how they enhance the productivity of data scientists, followed by a demo. First things first, let's talk about what is Amazon SageMaker. Amazon SageMaker is a fully managed platform service that removes a lot of heavy lifting to build, deploy, and manage machine learning projects. It's a single IDE environment which provides you capabilities in a modular fashion for all the stages of a machine learning project, starting from data analysis, feature engineering, data pruning, and moving on to training, validation, verification, optimization, and building feedback loops for your machine learning project. Whether you have a custom built model or you use a pre-built capabilities, most of the use cases can be catered by using Amazon SageMaker. Now, developing models can be done in a number of ways: on your own computer, or in Cloud9 environment, or on an EC2 instance by setting up a Conda environment with your deep learning AMIs, or a container environment. But one of the most convenient ways of building a machine learning project is by using SageMaker notebook instances. The front end of SageMaker service is actually the SageMaker notebook. These are fully managed Jupyter instances in the cloud to which you can bring your own notebooks from your local environment to explore and visualize your data and also develop your model. These notebooks come with built-in kernels, although you can install external libraries and kernels. Along with that, because data scientists love to explore different frameworks based on the data set or the use case they are trying to build their models on, SageMaker as a platform service provides a variety of frameworks based on the use case of your choice. Now, where do we start? In addition to understanding the platform, we have a dozen of pre-built notebooks available which can be used as a test to suit your specific needs, and it will make it easy for you to start exploring the platform. SageMaker provides you with a list of examples of a very common use cases such as recommendations, forecasting, for you to bring your data set and explore the platform service. If you are not able to find any of the use case of your choice, in fact, you can explore SageMaker Marketplace for more use cases and pre-built solutions. Now, when you create a notebook instance, we talked about it's a managed service. So what happens behind the scenes? The first thing you would do when you set up a notebook instance is you decide the right size, family of the instance type on which your notebook needs to be set up. All the data which is used as a part of this service is persisted in an elastic block store. So you create an instance which is created as a part of Amazon Elastic Compute Cloud behind the scenes, and the storage is created as part of Amazon EBS. Along with that, if you choose a different instance type for your inference, you have a choice of attaching an Amazon Elastic Inference along with your notebook to provide a separation of concerns between the compute requirements for your training jobs and for your inference jobs. When you set up Jupyter Notebook environment, you also get a provisioning capability to choose the network and the security configuration. Now here, based on the data classification level and the security requirements of your project, you can choose the number of capabilities. Along with that, when you set up your notebook instance, you can also set up lifecycle configuration, which are set of scripts which can be executed in the beginning of your notebook. Now, along with that, because we have created an abstraction layer for Amazon EC2 and EBS as part of a SageMaker environment, typically, to take a step further and understanding how this service works is, it's like any other managed service with a data plane and a control plane. The control plane hosts the platform agents to manage the data agents, log agents, and the algorithm. The control plane has all the instances and EBS volumes set up. These link to the AWS user accounts via Elastic Network Interface. The data plane has the core data required and the script or the code to build and train your machine learning model. We noticed that SageMaker Notebook instance provides data scientists a managed capability to build up their machine learning projects. However, with the experience and experimentation with the managed Jupyter Notebook, we have received feedback from the users to provide capabilities related to effective collaboration within teams and across teams, and also have a standardized environment for the model development, catering for different instance types and kernel versions and their associated dependencies. Users are also looking for reducing the learning curve and have separation of concerns between data scientists, DevOps professionals, and data engineers in terms of accessing this platform. With that in mind, this is where we have introduced SageMaker Studio Notebooks. Amazon SageMaker Studio Notebooks is a fast starting shareable notebook environment, and it provides you access to that environment via your corporate credentials. You have a capability of doing effective user management by having the admins or the core DevOps engineers manage the environment, provide you a link which is a bookmarked URL available for data scientists to use and start exploring. This way, data scientists do not have to understand in depth how the AWS management console operates, and they can just focus on building and their own models. Amazon SageMaker also enables one-click sharing of notebooks and make collaboration among teams very effective. Along with that, it provides you a capability of starting your instances much faster. There is a concept of fast launch types where the instances are spun up in less than 2 minutes. Along with that, as we understand, different steps of machine learning require different amount of compute. So within the SageMaker Studio Notebook environment, you can dial up or down your compute resources based on the stage you are running your machine learning project. Let's understand what the SageMaker Studio Notebooks comprise of. A SageMaker Studio Notebook runs in an environment defined by the following. It has an instance type, which is the hardware configuration the notebook runs on. This configuration includes the number and the type of processors and the amount and type of memory. The instance types also determine the overall pricing and the costing. Along with that, the Studio Notebooks consist of SageMaker image, which is a combination of the language packages containing your libraries, your frameworks, your binaries, and all your dependencies. Along with that, the kernel. Kernel is nothing but a conda environment for you to have an executable environment to run your machine learning projects. Hence, Studio Notebook is a combination of instances and a SageMaker image. Now, what kind of capability we get when we set up a SageMaker Studio environment? As a user, when you log in, when you open the Jupyter Notebook or on a SageMaker Studio, it is an extension to the Jupyter Lab interface. The primary features are the same, so you'll find the typical features of a Jupyter Notebook and Jupyter Lab. It's an IDE. We typically call it as an experience to the data scientists and the practitioners. Now, with that, as a user, when a studio environment is created, a domain is set up. A domain is comprising of the list of users who have access to the studio environment, and an elastic file system volume is created. This persistent store is created so that all the users within the domain have their private home directory on which they can build their models and run their experiments. Along with that, domain provides a capability for you to have integration with multiple users in the environment. Now, how domain works with EFS is that there are a private specific subnet IDs in which domain is integrated with the EFS environment, thus providing you a much more secure environment. Now, having access to a persistent storage means if the instances are shut off or are killed, you still have access to your data sitting on your home directory in an EFS volume. Along with that, with the studio environment as an IDE, the data scientists can access capabilities like autopilot, experiments, debugger, model versioning and monitoring, and all these capabilities are backward compatible. So users have a single pane of glass view of all the machine learning projects they are executing. Now, a user within a domain has a one-to-one mapping with the EC2 instance, which means that you have a dedicated compute resource, and also that compute resource is elastic in nature. So unless you want to increase or decrease is up to you based on the kind of experiments you are running. And along with that, one thing to keep in mind with Studio Notebooks is that unless you turn on the kernel, you are not incurred any cost. So once you start the kernel and start executing the notebook, the cost starts to be incurred. So keep in mind the cost model of Studio Notebooks. If you're in a non-viewable mode, then you'll have to incur cost. If you are just viewing the notebook and understanding the steps, even if it's an output, no cost will be incurred. So you can clearly see that a notebook running in a domain environment gives you much more advanced collaboration capabilities among your users. Let's dive deep into some of the features. In data science teams, multiple scientists often share a single AWS account. Data scientists don't want to use the AWS console, and IT team doesn't want them to use that. Hence, SageMaker Studio Notebooks comes integrated with AWS single sign-on as well as IAM capabilities to make it easy to use via your organizational credentials. Now, as we mentioned that there is a one-to-one mapping between the user and the EC2 instance. So how do we make the sharing and collaboration effective? This is done by using snapshots. By using a read-only copy of the notebook through a secure URL, you're able to share the notebook across your teams and collaborate more effectively. With Amazon SageMaker notebooks, you can easily generate a shareable link manually, tracking dependencies to reproduce the notebook code. When you do that, as you can see, you get a shareable link, and with that shareable link, the fellow users can access the environment and work on an existing notebook. If you turn on the output, the users won't have to rerun the notebook again and will be able to provide you guidance on an existing training which has been completed or any parameters which need to be updated, hence optimizing cost and also providing effective collaboration. With SageMaker Studio notebooks, there is a capability for flexible compute. Switch to compute with more memory, more CPU, more GPU acceleration when you need, and then come back to inexpensive one by just a click, making the experience very seamless and developer friendly. Administrators can also choose which instance types are available for the teams to use. SageMaker Studio Notebooks also comes up with the capability for you to create custom development environment. Until recently, you were able to use pre-built images with SageMaker Studio environment. With this new feature, the ML platform teams can directly attach approved images to the Studio domain, and once they do that, they can use that within the SageMaker Studio Notebook environment, giving a more standardized and customizable experience to the data scientists. Having the capability of customizing environments and standardizing security comes up as priority number one, especially if you are working in enterprises. SageMaker Studio provides security hardening capabilities via the encryption at rest and motion, and also VPC support directly. Along with that, developers have full control of their development environment, wherein they can bring their own image or view and shut down instances in Studio whenever required. Now, let's look at the demo and look at Studio notebooks and notebook instances in detail. Let's open AWS Management Console and look at Amazon SageMaker. Within Amazon SageMaker, at the left-hand side, you will see the dashboard with individual components reflecting different stages of a machine learning process, starting from data labeling to processing, to model creation, to training, to deployment. Let's create a notebook instance. Firstly, you will provide a notebook instance name, and then you will select the compute option for the Jupyter notebook. You can choose to associate an elastic inference for a separate compute option for your inferencing stage. Now let's create a new role, and for this role I'm going to associate the permissions to a specific S3 bucket, which is having the data set I want to use when I'm building a machine learning project. So a role has been created and associated with the Jupyter notebook. If there are any encryption requirements or data classification requirements, you can do so here. And if you have any networking configuration based on your environment, you can do a VPC configuration here, or also link a Git repository if your notebook is in Git. Once all this setup is complete, we are going to wait for notebook instance to be created. Behind the scenes, it's creating the EC2 instance and the EBS volume. Let's explore lifecycle configuration while we wait. Lifecycle configuration is a set of bootstrapping scripts you can create, which are executed when you create or when you start a notebook. You can also see we have a list of curated scripts available if you want to use that within your lifecycle configuration. These typically help you standardize your environment, and you can optionally do this step. Now coming back to the notebook instances, when the notebook has been set up, it will be converted from pending to an in-service status. And once it is in service, we can go and explore the contents. Looks like the notebook is in service now. And now we can open Jupyter and access the tree view of the environment. Within the tree view, at the right side, you can see the list of associated frameworks, and you can choose to go to terminal and set up your own libraries or dependencies. Let's go and set up a notebook using an example. For the purpose of this demo, we will use an XGBoost direct marketing algorithm, and we'll create a copy of it. As soon as we create a copy, a Jupyter notebook environment will be set up. If you are a data scientist, you must be familiar with this environment. The only difference being it's a managed service and being set up. So you provide the bucket name where your data set is there, and you can see that in this example notebook, all these steps are already set up, starting from getting your data set, to viewing and analyzing the data set, to further training, and then building an endpoint for inferencing, all within a single Jupyter notebook. Like any Jupyter notebook, you will run individual cells to produce the outcome and explore the end-to-end machine learning process. You can also bring your own script, or you can bring your own container, or you can look at some of the examples in the marketplace. When you do all these steps, you can also look at individual outcomes within the platform service. For example, you can go to the models view and look at all the models which are created as part of your notebook process. And you can also go to endpoints and have a view of all the endpoints created for running inference. Now let's explore SageMaker Studio environment. In Studio, you can either do a quick start, or you can go ahead with the standard setup. The standard setup provides two authentication methods, single sign-on and IAM. For the purposes of this demo, I chose single sign-on, and then I create an IAM role associated to the Studio domain. Further, I can choose to set up notebook sharing configuration and the setup which I require for encryption if there are data classification requirements for the same. You can also choose to set up the network specifications here, your VPC and your subnets based on the requirements of your environment, and further associate tags. Now you will notice here you have not created any instance specification. That's the core difference and defines the elasticity. Now you can see we have two Studio users associated via SSO. You can choose more users, and then looking at one of the users, I am going to open Studio. This is the Studio environment. At the left side you have different components to set up your folder structure or your file browser, look at your terminals and kernels, associate a Git repo if required, and further run certain commands. And then look at the list of experiments. If you are creating experiments, you can browse your experiments over here and choose different parts of your cells to do experimentation. Let's go to the terminal and look at where exactly you are in the Studio ecosystem. So when you do a PWD, your present working directory, this is your dedicated home directory as a user of the Studio environment. This is where you will have all your scripts and your notebooks available. Now let's go back and open a Studio environment with a notebook. This is one of the notebooks which I have ran and executed. At the top, in the right hand side, you can see the options for looking at kernel and instance specifications. You can also look at a capability to switch instance type, a capability to switch kernel. Now, let's look at select kernel. So here you can choose to select a preferred kernel for your Jupyter notebook. And then you can choose to define an instance type required. In the fast launch, you have the instances which are available in less than 2 minutes. And then you have the big list of all the instance types available for you to switch. So by just the click of this icon, you can actually switch to a different instance type. Okay, now let's explore other options we have available. As I mentioned, sharing and collaboration is seamless. Just by the click of share, you can create a shareable snapshot. You can choose to include the output of the Jupyter notebook, and that will create a read-only link that can be used to collaborate with your team. So you copy the link, and then we will sign in as a different Studio user within the same domain to access the read-only copy of this Jupyter notebook. Now, advantage here is that having a read-only copy means and having the view of all the outputs, you don't have to rerun your notebooks. And you can review and provide feedback on the outcome, the parameters and loss functions via just reviewing the contents. So if you can see, it's a read-only preview of your notebook where all the output has been captured because we selected to capture the output of a notebook. You can provide feedback by looking at the outcome to your colleagues and based on then provide recommendations. If you want to change it, you can choose to create a copy of this notebook in your local environment and then further update it and reshare the copy as a snapshot view. So now I created a copy of the notebook to edit the notebook, and once I will finish my editing by changing certain configuration to improve performance, I'll pass it back to the data scientist. We can also create images as I previously mentioned. So you go to Studio and go to create image. Here you can provide the URI for the Amazon ECR, which is the repository which has your images. And once you have that, you can attach the image by clicking on attach image and link that image to your domain. It's that easy. So once you have a containerized image available, you just have to attach the image to your domain. Now, where do we get these images from? As I mentioned, we'll have to go to Amazon ECR, which is the container repository, to set up an image. Now, within the Docker container registry, I have already set up a custom image for R. So you look at this Studio image, and if you click on it, this particular custom image is for R. And what I can do is I can copy the image URI and associate that with my Studio domain. Let's do that. So I've copied the URI. Now I'm going back to SageMaker, and within SageMaker, I am going to create an image, provide the ECR image URI, set up image properties like give it a name, give it a display name, and all the relevant IAM permissions. And once I do that, I will submit this image called as reinvent demo. You can see the image has been created with a version. I take that image and I attach that image to the studio domain. When I do that, that image with our kernel is available to all the users in the studio domain. So I have selected a particular version of the image, specified the image properties, associate the kernel as R because that's a custom image for R, might choose to do some advanced configuration, and then click submit. The image is now associated to the domain. I can go into the launcher and look at that image sitting in the list of custom images. So you have SageMaker images and then you have custom images. So we click on this image and then create a new notebook using that particular custom defined SageMaker image with our kernel. Once I click on that, I should be able to see the image associated with my notebook, and I can do regular notebook creation steps. Hope this demo provided you insight on how to use SageMaker Studio and also notebook instances. These are some of the additional resources you can look at. Thank you, and please make sure to complete the session survey. Enjoy rest of reInvent.